Okay, thank you, student, for joining tonight. And we're going to discuss Chapter 7, Arrays. And I'm going to demo some of these examples between C++ and Python. And now we're recording everything. And we have 80 students all together join in so far. And we're going to go with these examples of using a for each statement. So let me open up my screen that I already set up here. And I'm going to just open up the file here. Okay, and so clear the screen, vi demo1.c++. Let me just take this line out, and this is an array. Let's make it 5 elements here. And then we do 10 also. So, so 5 elements, the size of array should be 5 here. And then this for each statement is going to print out and this data structure array of integers from 2 to 10. Basically, each element will be printed out like this. And then int x is, in this case, is going to be 2, then 4, then 6, then 8, and then 10, and then end of array. So this for statement doesn't have any block of braces start and end, because only one statement, and we want to separate them by tab. Then when it is done, we just at the end want to print out a new line character to just make the format a little bit nicer. In the top, I just saved this one. Now let's just make this one 5 elements now, because it is a little bit different than the previous session, and 10. So now we're going to compile it. In order to compile this one, cat -n demo1.c++, I'm going to do a g++ -o demo1, and then the program name is demo1.c++. So it has an error. It says that array1 was not declared in this scope. So whenever you're trying to use an array name, make sure that the name that you use is the same. So let me just go there and then say vi, and then here I used the variable on every place here, array1, but I named it based on the previous session as array. So that is one typo. The array name is array1. Now it should get rid of all those errors. So if I compile it, now it compiles. And then if I run it, demo1, it just says there are 20. This 20 is actually the size of the array, how many bytes it contains. Because there's 5 elements on it. 5 elements on each element is an integer. An integer is 4 bytes long. So 5 times 4 is 20. This is 4 bytes, and this is 4 bytes, this is 4 bytes, this is 4 bytes, that's 4 bytes. 5 times 4 is 20 consecutive area of memory is allocated for this array. So let's just look at that example of sizeof and just declare another array, and I'm going to call it array of 2, and then I'm going to just make this one another 12, 14, 16, 18, and then 20. So this one is having 10 elements. 10 times 4 should be size of this one should be 40. So in order for me to print that one, I could say this, and then I could put another array of this, but because I put this in line, I'm going to just cut and paste these 4 statement, 1, 2, 3, 4. So 3 of these ones, I'm going to YY and then paste it here. So paste it here and then add another line here. So at this time, and for the second array, I'm going to change this one And then look, for this one, I need to do this and then print it. So notice that now I have two for each statement. One, it goes to print out array 1, and the other one is going to print array 2. But notice that array 1 size should be 5 times 4 integers, 4 bytes integers, that's 20. The next one is 10 times 4, and that's 40. So let's just run it to see if we get the correct size for the second one. I'm going to compile it again, and then the compilation failed because some error on line 27, 28, I'm having something incorrect. So let me correct that one. What is that extra line here? This return and this one was copied more from that previous one. So that's what that error is. And then I'm going to save it and then compile it again. No error, demo 1. And then now this time we see the size of array 1 is 20, and then these are the element of it. And then size of array 40, these are the elements. So now we're going to put some cout statement just to make our code more readable, because when you say size of this one, we should actually say this statement, that size of array 1 is equal, and then we just do that one, and then a size of that. And then the same thing, I copy this one and put it here, and then this one I take it out, and then I say the size of array 2 is, and then print out and the size of, using the size of function on array 2. So now let's clear the screen and then print it out, compile it, and then run it. This time we get a little bit cleaner, but it's still the elements are showing there. We don't know, you know, what are there. We should have printed out the elements. You can put that for a cout statement to do that as well. But notice the size, because an integer is 4 bytes. The first one, 5 times 4 is 20. The next one is 10 times 4 is 10 times 4 is 40 bytes. So let's compile it one more time and modify a little bit here. At this time, if I want to just print out each elements of this one while I'm on the this statement, for X statement, I could use, or actually for each statement I could use, or I could use the regular for statement. The difference is that the regular for statement, I have to have an incremental value, how many elements I want to move on to the to the elements, and how I want to print it out there. So let's just write another for each statement, or we could even use the for each statement here to do that. So here, like, let's say if I want to just say x plus 2. So whatever the number it is there, we could move on to that number, cout with adding to it. This is one way to do that. Another way, you could use a for statement here. Let's just do a for statement right after the second one, because we're demoing something here. So this time, we're going to just say using a for statement. So a regular for statement, in this case, I'm going to say for int I is equal 0. So I start from the first element, and let's do the bigger one, the array sub 2. We say the size of array is already determined, because there's actually, this is 40 divided by the thing. So if I want to just get the size of the how many elements are there, I could also calculate it like this. So here I could just say array size of, or just create a variable size of array 2. Size of array 2, if I want to get the size of array 2, it is basically the size of array 2, which give me 40, divided by the one of the elements, which is could be array sub 2 the 0. This one is 40 divided by 4, that's 10 elements. And then the same thing here for the size of, this one, if I want to copy this one and put this one size of array sub 1, and I could just get the size, this, and then divide by this. And so what is that telling me? Let me just clean up a little bit here. Array sub 2. Okay, so this is one, and then the C out is another one. Okay, so the let me put the line numbers, set and U, set and U. And then line number 10, I'm having an integer type array ARR1 with 5 elements of integer each. And then each one is 4 bytes long. If I want to get the actual size of, the actual size of it, the actual size of it, size of function is returning me how many bytes of storage array sub 1 has, which is 5 times 4. For each integer is 4 bytes, and there's 5 elements, 5 times 4 is 20. So this one is going to return 20, but 20 divided by 4 is going to be 5. So that is basically, if I divide it by array sub 0 or array sub 1 or array sub 2, or divided by int, in this case, is the same as dividing by array of sub 0. An int is 4 bytes long. And here I could do the same thing and divide by int. But then if I don't want to do that one, I could just show you here, array sub 2 of 0 is also 4 bytes long. So 40 divided by 4 should give me 10. Now the size of is there. I'm going to just say here, say, for I less than size of array 1. So for a size of array 1, we want to print the first one there, I plus plus, and then here we could just say, go ahead, print out array and C out, and then array 1 sub I. And then if you want to just tab it with each time that you do, you could do that with tab spaces. And they're not next to each other. And then every time you print the next one, it comes out, print the first one and then tab, then print the second one, tab, and so on. So this one is printing that. And now I need to do the same thing for the second array using the for statement. So let's just do another one of 28, 29. These 2 lines I'm going to copy, and I'm going to paste it here. And then I just change the I. I could use the same variable. I don't have to use if I don't want to. I could use it. It's okay. But I'm going to just do that here. And then all I have to do is the element that I'm changing, also that one has to change. So instead of doing the array and size of array of 1, this time we are doing the second one. And then in order to just make it more clear here, let's just put a couple of YY, and then we just say paste here, and then we just say the number of elements for ARR1 is and then we say size of ARR1, and we printed that one to do that, size of ARR1, and everything else is okay. And then we are going to do this one also for the second one here. And then the number of elements for array 2 is size of array element 2. So let's just save this one, and then we just compile it. And then this time failed. Let's see why it was not declared in the scope. Size of ARR1. So maybe a typo on the name. Size of ARR2 is not declared. Int primary expression before int I is that. So let's go one by one. Line 2, it says size of ARR1 is not defined. Sometimes once you fix the first error on line 11, column 2, then you fix other ones. But let's go on line 11, line 14, and 33. See what are on the typos. Most likely some typos. Set number, and then go to line 11 first. And we say size of. First, we have to do an int, the data type of size of there. And then for size of this one, also we have to do an int. The data type, I didn't give a data type. I assume that I already declared somewhere. So that those line 11 and 14 was solved. I believe line 30 was also there, but line 30 might be as a result of those variables not defined yet. So now we know that even though those variables are defined, this int is not recognized here. It says expected a primary expression before int. And then this expression, I'm going to put this one between brackets, and then or between parentheses, sorry. And then this other one, it says error I was not declared in this. So I use J, and then I should have used J here too. So J, and then right here, I had to increment J, because when I copy, I forgot to update that one. But this other one that it says size of, this is not declared. I'm going to try to do this because an integer is 4 bytes, and see if that resolves it. So it did not understand that one before this. Let's see size of AR1. Expected this. I want to make sure that I'm not having a typo on line 11 here. This is semicolon, size of int, and I'm going to try to say ARR1 sub 0. Maybe the int type is not, is thinking that I'm defining another variable somehow. So G++ minus O, C++, yeah, that was the only issue. So we did run it here, successfully ended. And now if I run the code, call it dot and demo1, notice this time we're getting some kind of information here, the size of this, but we need some more end of line statements, because once it print this one, the number of array element is 10, which is accurate for this one, and then the number of elements array of 2 is 20. That's okay too. And the values, we're printing it all good, but somehow some of the values are coming too and say that it is off, because maybe we are printing a little bit more than what we should do. So let's go back to our for statement. And then we are going to VI the code and look at this. This one is giving us size of that one, and which is going to be 5. Array sub this is 20 divided by 5 is 20 divided by 5 is 4, and 1, 2, 3, 4. This is why it's not good to just declare the size of, because of the compiler. Sometimes they could be undefined variables and the size of it. So it's not recommended to do this kind of calculation when you're looking at the pointers values, and different compilers may throw different outputs. I'm going to just do it a different way, which is a better way than just declaring it those way. We rather have constant value, either local to the main function or globally defined, and we call it. So the size of is there because this is less than, and it should have worked with that number. And J++, J is 0, J is size of, because it returns 10, and actually, if I just change the code here to -1 here, and then also this to -1, most likely our code is gonna be fine. But I wanna just make sure that we don't point to a memory location that does not belong to us by doing this less than. Since this one returns the size of the array, which is 20 divided by 5 is going to be by 4 divided by 4 is 5, and then we want to just make sure that it's less than 5. So we could do that one, and then that one is 5, and less than 5, we should do that. And then also I was saying that I'm going to do some more cout, and then right here, I'm going to put a new line character to clean up those messy output. In here, I'm going to print out a new line character. We already did this one. And then right here, there's an inline here, but not another inline here. So when we do that one, and we could just clean up a little bit more here by typing this and pasting it here. And then one more. Even though I put this new line character here, I'm creating 2 of them just to clean it up a little bit. So clear, and then compile it, and then run it. And now we're getting still these memory element that does not belong to us. We got up to 2, 4, 6, 8, 10, and then all of a sudden we're jumping into some other memory location, which shouldn't be our case. And then this other one there. And the reason might be because of the variable usage. Let me make sure the variables or change the for statement. I'm not doing for both of them the same size of elements. And then size of 2, size of 1. Yeah, so the one of them is size of 2 and the other one size of 1. So instead of this n size of 2, and instead of this n size of 1, I'm going to create 2 constant values. I can create it here or inside the functions main. I could, whatever I want to do it, that's fine. Constant n, and we're going to say size of ARR1, and we are putting it to 5, the first one, because there's 5 elements. Constant n size of ARR2 is equal 10 elements. That's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 elements. So let's try this one, and then because we are commenting these other ones, now our code should be working as expected. If it doesn't, we will fix it more. So the first one, it worked perfectly, 2, 4, 6, 8. It did not print the 10. The next one, it prints 2, 4, 6, 8, 10, and then all of a sudden, some other values that are pointing to some other memory location that does not belong to us. It should have printed out the first one 8 and then 10, and then the same thing. Because on the array, I said -1, so it did not print that one. I need to just take that minus out, 1 out. we don't need to do less than the number of elements. Otherwise, we miss the last elements if you do -1. Here, the same thing, but let's look at the fact that size array, oh, this one array sub 1, this one is array sub j sub 2. That's a typo. That's why we were getting garbage on the second one, because after the fifth one, there was no, like after the 10, it was nothing there. So in this case, we clear our screen. No, I don't clear the screen this time, because you could see the screen looks better now with the output. We updated it. So the first one is printing out all the 5 elements, and the second one printing out all the elements. And this W-Lutfi, it should go to the new line actually. After this print out the second one, I need to do another VI, another cout, right? This other last statement, and then we could just clean out more. Usually your code should just do a couple of inline just to make sure that your code in the program that runs behind you like this does not make it. So this is my prompt. This should not be looking up a part of my program. So now if I run it, it's much cleaner. It just writes the 20 and then it gave me 2 lines before it gave me the prompt. So this one is because of the size of elements, we already defined it. We did this one. And now let me look at the time, see how we're doing, 8:09. So I'm going to demo how you're going to write like a function that uses array as a parameter. And then please ask question if I'm not clear on anything, and make sure that you understand that one. So let's just copy the demo1.c++ to demo2.c++. And then we call it the demo2.c++. And then this one, we just add this one, say, now we like to use a function that uses array1 as a parameter. So this is when we are passing array as a parameter. The other second part of array, we're going to delete this. The other ones, we don't need it. And then we only work with the first one. So the array sub 2 is gone. And then this one was a demo of examples of this. We could, we don't have to do a for each statement. Let's just make it with for statement first. And then if you want, we can add the for each statement at lab activity. You can work on it, or vice versa. One of them we can leave, the other one you can just work on it at the lab time. But let's just do using a for statement to write this function to print the array size, whatever is the array. So here we are not doing this anymore. And then this last part, the size of array sub element 2, I'm not going to do that either. And then get rid of this. Okay, so this is all good, clean up, but I want to write a function. Let's call the function name called, sorry, somehow my screen. I'm still sharing everything. You guys see it, right?
Yes.
Okay, cool. Thank you for confirming. So I'm doing this. I'm going to declare a function called void and then display an array. And let's call it display array1. The name of the function, we call it array1. And since it's display, and then we want to just go into kind of like a little bit with camel face naming, I'm going to call the function name display array1 array. So in this case, we're doing a function And then in this array, the first one, I want to use a pointer to an array. I could only show this, that's at the declaration, I could only do this, and that's a still valid C++ code because it says I don't have to give the name of the array. I don't have to do anything. All I could say, it takes two elements. One is the array, the other one is an integer, which is the size of. But if I want to be a little bit more friendly and helpful, I could just say my array name is ARR1, and then this element is the size of the array that is based on the size of ARR1. So that's the size of ARR1 that I will pass in and do this calculation on it. So this is the declaration, and all it is, the prototype, it requires a semicolon. I'll put the semicolon here. Now I have to write the definition of that function. So the definition is easy. You just paste that thing, take a semicolon out, and then put a brace, start here and here, end, and you're done with the definition. No, you're not done with the definition. We just declared an empty defined function. And now we have to actually define the function, what the display do. So the display, like I said, it's easy. We already wrote the part of the display here, the for statement that we did. And then the number of elements for the array, we can just use that one from the main, or we could just put it into the thing. Because this one is also passed on, I'm going to cut and paste from this line, this line, this line. And even these two lines is good for the end of the main function is fine. So these three lines, I'm going to cut and paste, and including this, for and DD, and then I'm just gonna paste it here. So now we have the function that is basically doing the work of display array. The display array is gonna look for I is equal 0, size of. The size of is already passed on here. And then that is going to be a parameter that we pass on by the main when we call the function display array. And then the other parameter that we pass on is also in the main, and that is the array1, which is already defined there. So the size of is also defined inside there. So we are going to just do that one. And here, and this end line, you don't need that one. We're going to just say, call the function, call the display array function. So when we call it, the call is just giving the name of the function, display array, and then the parameters, if it's an array data structure, you just say array1. You don't need to do this bracket, or you don't need to put pointers or anything. So in this case, it's just the name of the array. That is all you need. And then you don't need a reference also, because this is an array. Array by itself is a reference. It's a pointer to the first element of the array. So we are going to print the size. The size of it, if I want to do 5, I could do, or I could say size of array1, because that size of array1 is defined. Size of array2, we don't need it because we don't have that one anymore. So that one is removed, and then everything else is here is needed. So all we did was call the function display array. We declared it here, we define it here, and we used it here. So let me just go back again here, put the line number. On line 9, I declared or prototype the display array. On line 22 through 28, we define it. And then on line 17, we used it. or we called it, or we invoked it. So let's just compile this one, see how it works. I'm gonna just clear my screen and say G++ minus O to create the program demo1 from demo2 from demo2.c++. And now I have an error. It says expect a semicolon before cout. That's a very easy command error. So let's see what is the missing semicolon there that we need to write here. When we did the call, we forgot the semicolon. So that is good. And then now we compile it again, it should work. And it did. Now demo2 is going to give you the number of elements for array is 5, and the elements are there. Notice how simple it was to write a function that does use an array as its first parameter or second. Because we know the size of it, it's going to come in. Notice we did not give a number initially here. But if you're doing a two-dimensional array, then it's going to be a different story. Let's just do the same thing as a two-dimensional array. So I'm going to copy this demo2.c++ and call it demo3.c++. Now vi demo3.c++, and we just add this one. We say this time we will use a two-dimensional array. Two-dimension array data structure. These are kind of good chapters for your data structure class. Later on, when you take the data structure class, you will learn arrays, strings, and vectors, and classes, and other data structures, depending on what classes you take. You could take maybe advanced class for mapping, which is called data dictionary, and Python, and in C++ is called map or hashing. And then for list and tuples, arrays, and vectors are there. Vectors is really good. Vectors is dynamically dynamic arrays. So with you can dynamically grow the size or shrink the size of the vector or the matrix or the array. But with array, it's fixed size. You cannot resize them. So now if I want to just do a two-dimensional array, let's just call it still array 1. We don't have to change the name. At this time, we're going to call an array of 2-dimension. All it is a 2-dimensional row and columns. So this is the row, and the first one, and the second one is the columns. This is row, this is columns. So if I want to do that one, now I need a little bit more parameters than the size. So here I need to have for end rows and then end columns. That is what my display array is supposed to do. It has to have 2 elements. So copying this and changing this to that would reduce it, and then I'm going to take the semicolon out. Otherwise, it would be like an infinite loop or errors in there when you're missing, adding a semicolon where it doesn't belong. So here we define it like having 2 elements. So I'm going to also do the 2 elements here. And then I'm going to also do 2 elements here. And then now our array is not 2 elements here. So the 2 elements we're saying, let's say we are doing it 2 rows and 3 columns, for example. 2 rows of 3 columns would have something like this. If I have one array of 3 columns, let's say we call it 10, 20, 30, that is 1 column. And then another row would be 3 columns again of 40, 50 comma 60. So this is 2 rows, and then this is 2 dimension. So whether I write here size of it by number of rows, sorry, I'm going to just use variable rather than having number here. I'm going to say, let's see, x. I'm going to say rows, and then here I'm going to say columns, and that. So now I did that, and I'm just going to say, and then this one belongs to right there with the formatting. So now all I have to do is make sure that instead of int array size, I'm going to say int row is equal rows, number of rows is equal, let's say we have, in this case is 2 rows, because this is 1 row and this is a second row. Number of columns is 3 columns. This is 1 column, 2, 3. 1 column, 2, 3. So that's number of columns. We're going to say constant int columns is equal 3 columns. So it's an array of array. What I mean by an array of array? Array of array in 2-dimensional, there's 2 arrays here. This is 1 array, 1 dimension, that has row 0 with element 0, element 1, element 2. And this is a second row, which is the second array. So that's why we call it array of array. This array contains 2 rows and 3 columns. That's why we are having the 2 rows and 2 columns. So if I'm just referring to the 60, if I want to get the value of 60, then I have to say ARR1. Let me just write it here so you know what is this. As a syntax, to get the value of 60, you say ARR1 sub 1 and sub 2. Why sub 1 and sub 2 is the value is 60. And why? Because this is first row, this is second row. Second row is this one, 1, and the value 0, 1, 2. Column 2 will return this. Similarly, if I want to get to 50, ARR1 of 1 and 1, because the row 1 is going to give me this row, and then the column 1 of that row is going to give me 50. Similarly, if I want to do the 30, I would be ARR1 of 0 and 2 is equal 30. So this is how you are pointing to that. When you go to 4 elements in each of the sub-arrays, you're printing them, and you're going to use 2 variables. So here, we already define our array, but now we are using the columns, we have to print it. In order to print it, we're using 2 variables, I and j. This one, and instead of size of, this time we say rows. And then after this one, we're going to say phrase, and we say for j, or int j is equal 0. What should be j less than? To point to columns, you have to say, the first one is for the rows, and the second array for statement is for the columns. So this one, 2 times 3 is 6. There's 6 elements in the entire array. We're going to get everything when we nested these 2 states. So now j plus plus, and when we are saying that, go ahead, do this cout statement, and then close my for statement. And then this end of line is already there for it. We could even do one after this if you want to, but because we're printing it in the main, so it's okay. We just don't have to do that one again and again. So here I'm going to compile it now. Let's see if it fails. I'm sorry, demo 3. Demo 3 if it fails or not. Demo 3, and a lot of errors. So let's just correct them. VI and demo 3.c++. Obviously, some of the things that we did here is that say compile it, and it says declaration of AR1 as multi-dimension array must have bound for all dimensions except in the first one. So these ones that when we are doing it, it is need to be bound to the value. So right here on the function, the declaration, we need to just do these, say rows and then columns. And then since we're using these ones in the prototype, we need to move these ones as global variables here rather than local. So now this one is there and this one is there. The rows and columns is defined here, but we need to also do rows and columns here too. Rows. This constant cannot be empty on the two-dimensional. They have to have some value defined. But on the demo 2, we noticed that the empty was already picked up from the size of the elements there. So let's just compile it again, see what errors, shows up errors still. So this time it's a different error with different numbers that are there. So line 20, before this one, it is saying that it's there. And then line 25, and there's a columns there, and then line 26, return, and so on. So let's first fix line 20. Line 20 must be missing like a comma here. This one, a comma is needed, but this one you don't have to because this one is right after that one. So for the first one, you need a comma. And by fixing that one, let's just compile it again. Well, now we have other errors on line 24. So 20 got fixed, and then size of array is no longer needed. So that one, a function calls to that one needs to be corrected with rows and columns. Line 24, 28 is columns, call rather than columns. So 24 is a typo, 28 is a typo, and the rest of them are all good. So let's go to 24. Here we say display, and then we are going to pass on the argument of rows, columns, because the function display array is not like demo 2, it's demo 3 has 3 arguments as we define it here, number of rows and columns also. So we have to pass in the proper number of parameters to it. That is 24, and then 28, what was there was somehow the word columns or calls was used, rows, columns, and right here. So this function, I missed the word calls and then the bracket for columns. And then here also I had COL, and then I'm going to change that one to COLS because the constant that we call it calls and not COL, columns. So call, and then right here needs to be corrected. The nice thing about this VI, I could search for COL and then say wherever I use the word COL and find it for me. I can do next, 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 and it's gonna just find it on all of them. And if I say I missed it, let me just go backward, uppercase N will go backward. So I found all of them and all of them are good. Now I compile it. This time it should compile. Okay, the size of, again, on line 31 is a typo. Size of array, we should have not printed that one. Because you copy from another function to another program to this, we have to change this one. The number of elements for array, and this one, we, instead of doing this, we say the and the two-dimension array, we could just put a different wording for this one. The two dimension dimension array, ARR, so we could say here ARR 1 rows we could just call it like this. As of that, we could just put it here 2 and 3, and then here we just column rows and then columns. Columns, that's we say 2 by 3, and then in order to just write that one as also as the way we want to print it, we could put this one in a nice format array of this, and then so rows 2, and then it's going to basically write exactly what we are writing here is equal, and then we're writing that number then there too. And then here we're going to just do a less than sign rows, and then another less than sign, just close that one, and then the second one, and then open that one, and then do another close of that one with this. Let's just do that and then compile it and run it. Clear, compile it, and then run demo 3. So now you see that it printed out the two-dimension array, arrays of 2, 3, and then arrays of 2, 3. But notice that we are printing only the address of it rather than the actual element of it, right? For the size. Let's see why we're printing the address of it rather than the element of it. So if I go here back on the VI, can somebody guess it before I figure it out? Why is it printing, when we are printing arrays of I, okay, it's obvious by looking at it, right? You guys know why it is, right? That's obvious. So instead of having, when we go from I to J, if I just print arrays of 1 of I, that's a memory address for it, for that element. But I of J, now I'm pointing to the actual values. So let's just compile it and run it. And we are getting those values that we want to print it. And if I do cat minus n and demo 3.c++, you could see that we're having those values, 10, 20, 30, 40, 50, 60, and each one of them we're printing the value that we want. But I want to just say that I want to get on each element, I want to print out the value for it. So let me, give me 1 second. I need to just put the alert off on this one. Okay, so if I just want to print this one, 10 being the first element and then 20 being the second element, this is what I'm going to do on the code. VI, so right here where we're printing here, we could just put an element of that one. On the cout a statement, cout, here I'm going to say AR, okay, let's go put it within the code, AR sub, and then code here, close, and then this, and we say I, and then start another code here, put the right statement, and put another one, and then close the code, and then put another one of J, and then another one, and then, sorry, another one, and then close it, and put an equal sign here, and double quote, and do that. So now we're getting a nicer output than before, because we want to just say the output makes sense when we look at it. So here, if I just clear the screen and say demo 3, notice this time array sub 0 of 0 is 10, array sub 0, 1 is 20. The first array, if I look at the code, let's say grep minus I ARR, actually one thing, pi demo1 demo3.c++, this thing I forgot the word array1. Right here, array1, and then this one, we want to show you this lines number. Line number, and that is set in new line 19 and 20. Okay, so if I just compile this code again, clear my screen, compile it, and then I want to just run it. Now it looks nice, but I want to just make sure that you see the actual array. Since I did not print out the actual array away from this one, I'm going to say grep grep minus n from demo3.c++, and then I'm going to say grep, and then look for line 19 and 20 and maybe 21 too. See if, or 21 and 22. From this one, grep minus sign. If I do this one, what is going to give me? Oh, sorry, I mean to do a cat here, not grep, a cat first, and then do those lines. So notice that if I just want to do cat minus n demo 3, and then I run my code, the demo. Remember I was telling you that the first element of this one is row 0, column 0. Row 0, column 0 is 10. Second one is row 0, column 1. This is row 0, column 1. Row 0, column 2, that is 30. And array 1, which is the second one, row 1, column 0 is 40, row 1, column 1 is 50, and so on. You can see the same numbers that we did here, all are accurate. Like this one, 02 was right here, and that's pointing to 30. The demo that I'm doing here is one for showing you an integer type of array, one for 2-dimension, one for just a regular dimension or 1-dimension array. And you can do it with multi-dimension array as well. Last time we did multi-dimension array here on my laptop. And then array 2-dimension, array of, so I call it 2-dimension here, but we did multiple dimension, I believe. Array of 2D underscore 2 dot C++ cat minus n array underscore. Yeah, so we did a number of elements, and you see that this one was array of 3 by row of 3 by 5, 3 rows, 5 columns. And then we did also a demo of multiple dimension. If you are interested, I could go over that one as well, either today or Wednesday. We can just go, the only difference is with 3-dimension, the number of elements is just rows, columns, and then the number of columns on that columns, how many are there. So it's array of array of array. And when we say a 2-dimension array of arrays, is that example that I was showing you. One element, one row is the first array, the second one is the second array. So array that contains an array. On the 2-dimension and 3-dimension, I want to demo one more things. Let me see, what was it for that 2-dimension? Yeah, if I want to just initialize the values by default, you can just use, let's say that the example of 2-dimension. So here we did those 2-dimension and with demo 3, I'm going to say copy demo 3.c++, and we call it demo 4.++, and let's just go to demo 4.c++, and then we just add another comma and say now initialize zero out all elements of the array with initial values of zeros. So this is just by default, whatever the value is, 10, 20, 40, 30, 40, we want to change all of that one to 0. So in order to do that one, we could write another function, say, let's say here, we could say, copy this one, and we just say, zero out array, or whatever we call a 0 out array. And so 0 out is good enough. So now we have those same parameters that we are passing, but we're just changing the elements of it to 0. So this one is much similar to this function, except we're just initializing them to 0, or changing the value of them to 0. So line set in U, I need to copy line 30 through 38, 39. So that's about 10 lines. I'm going to say 10 YY, and then I come back on the last line here, and then I say paste, and now I have the lines copied. So I'm going to change this one to function called 0 out, 0 out. And then the rest of the thing is all good because we're just doing this. I don't need to print out this, the dimension of array, because we already did that. So I'm going to get rid of that, this one, and get rid of it. So this for I and j is definitely needed. And then instead of doing a C out, we're going to just do all of a sudden right here, all the way here. And just do an assignment statement and just say assign row sub 0 and row sub column sub 0. The row and column, assign it to 0. And so whatever is those 6 or 10 or 20 or whatever number of elements are on the 2-dimension, in this case 6 of them, 2 by 3, so it's 6 of them, and it is just that. So let me just compile it again, G plus plus minus O. Actually, sorry, I missed one thing that I should do. C++, I need to make a function calls to that, right? To just show that the demo, this is the printout first, and then now we zero it out, zero out, and then we're gonna do this line here as well here, and then we're gonna do a display afterward. So once we zero out, we want to print out the rows first by calling display array, and then after we change it. So give me a second. Okay, now I'm going to save it and then compile it in G++ minus O demo4.c++, the demo4.c++. So there's a typo somewhere there, array rows and columns zero out. So the O, double O, I must have missed one of them, yeah, zero out. So that's a typo again, and zero out, only one part here. And this, I need to just make another O, and I believe that was the only one. Maybe there was two of them. No, it was only one. So now demo 4, you can see that the first time it print out these array elements 10, 20, 30, 40, 50, 60. And then the next time when we did the two-dimensional array, converted the value to 0, all of these elements are zeroed out when we print it out. Okay. Any question? Okay, I think we passed on way out of the lecture time. It's 8:49 because I missed a little bit on the last part of just not sharing my screen, so I redid those steps. Now you have the whole things, and I'm just going to post this one, so you have everybody have access to it, and you can follow up from there. And then please work on the lab activities from the exercise that we did last time, all the lab activity that was on the modules, work on those ones, and then as well as array of two-dimensional, and then some more of passing array as parameters, and ask me a question, and this is for you to learn. Right now it's 8:50. Let's take a 10 minutes break. At 9 o'clock, you come back and work on the lab. And I'm gonna stop the video right now so I can post it later on today.